Yo, 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 Math by the Moon, back with another video. What I want to help you out with here today is solving radical equations, including radical equations with extraneous solutions. Then we'll also get into what it looks like when you have to solve an equation involving a rational exponent, when you might have to worry about two solutions with a rational exponent versus when you don't. So let's get after it. You ready? You ready? Ooh. All right, so what I have here on my document camera here is the square root of 7x plus 15, that's a binomial, equals x plus 1, another binomial. So the first thing you want to do is try and get rid of the radical, and the opposite of a square root is raising to the power of 2. So I'll raise both sides to the power of 2. And this is kind of an algebraic atrocity right here. Squaring a binomial, and if you're in my class, you know better, because I have like this thing about killing puppies or something. I can't remember if it's puppies or kittens. I think it's puppies. You can't kill the kittens when you factor. Boy, I should have pulled that together before I made this video. I'll see if I can grab it. X plus 1 squared means you have to write it out twice and use FOIL, and we're probably pretty good at doing this quickly, so let's just go ahead. X squared plus 1x and 1x would make 2x, and 1 times 1 is 1. The square and the root will cancel each other out. So this will be 7x plus 15. And now since I have a second degree, it means I have two possible solutions. To get those two possible solutions, we're going to try and get it equal to 0, use the zero product property if we can factor it. If not, it might be a quadratic formula. So if I were to subtract 7x and 15 over to this side, that'll get it equal to 0. And what I'm going to do now is think of numbers that multiply and add up. Hopefully I got a pair that's going to work, and I do. Don't forget, you're using the zero product property to find the solutions. So the solutions are what make it equal to 0. So 7 would make it equal to 0. And -2. Now, I have this thing up here that says extraneous solutions, and the very first few letters in that word extraneous are extra, and it's extraneous. It's extra insignificant, unimportant solution. So what happens when you're solving this algebraically is you get two answers, and possibly, since the answers are under a radical in the original problem, possibly you might have something that comes out to a negative, and you know you can't have the square root of a negative. Or maybe one side comes out to a negative and the other side comes out to a positive. So we have to consider these possible solutions to find which ones work, which ones don't. They might both, they might neither. So if I were to take this 7 and plug it back in, I would have 7 times 7, which is 49. 49 plus 15 is 64, right? The square root then of 64 is 8. Well, then I got to plug it in over here and do 7 plus 1. Well, 7 plus 1 is 8. So 7 works, right? So 7 is a good solution. When I stuff it back in, it works. Now, if I were to stuff the -2 back in over here, I get -14 plus 15, which is 1. The square root of 1 is 1, positive 1. Over here, if I stuff in a -2, I get -2 plus 1, which is -1. So here I get something where on one side it's 1, on the other side it's -1. So this one right here is extraneous, because when I stuff it back in, I don't get the same number on both sides. All right. So that's what happens when you solve a radical equation. You get two possible answers on occasion, and maybe one of them is extraneous. On the other hand, we might have to solve equations. They're very much the same here, because you know radicals and rational exponents, they're equal. So come on, focus please. Focus, there we go. So over here we have something that's being raised to the 2/3 power, which in my mind I'm thinking it's a cube root. It's a cube root that's squaring the result, and it's supposed to equal 9. in the video in Edgenuity, they show you, they go through the long drawn out process of converting it. I think it's just makes more sense just to talk about using the reciprocal power right from the jump, right from the start. The reciprocal power of the 2/3 is the 3/2. So if I apply the reciprocal power on the left, I also have to apply the reciprocal power on the right. So that's going to wipe out the 2/3, and the 3/2 are going to cancel out because they're reciprocals. When you multiply by a reciprocal, you get 1. So I just have x minus 7 equals. Now, here's the tricky part. We solved equations before where, when we completed the square, this specifically was where it happened in class. When we completed the square and we apply the square root to both sides, we immediately put up the plus or minus, because when we do the square root, you're doing the square root to reverse a square. When you square a positive number and the same exact negative number, you get the same result. So what we're really doing here is a square root of 9. So we're going to have to put up a plus or minus here, because we're really doing a square root of 9. We're the ones introducing it this time. So that's a plus or minus. The square root of 9 is 3, right? 3. And then we got to cube it. So if I take and cube 3, I could get 27, or I could get negative 27. So there's going to be my 2 possible solutions I need to run through. So I'll just add 7 to both sides. And 27 plus 7 is 34, right? 34. Or negative 27 plus 7 is negative 20. Now, we're still not out of the woods yet, because we got to make sure that we've solved, that both of these work, or maybe only one, or maybe none. So let's plug it back in. 34 minus 7. 34 minus 7. Well, that's 27, right? The cube root of 27, since I'm doing the root, would be 3. Squared would be 9. So 34 works. If I do negative 20, negative 20 minus 7 is negative 27. The cube root of that is negative 3. But then I got to square it, because the extra power, which would make it a positive 9 again. So they both work. So they both work. And again, the only reason why this is happening is because you're applying a square root on both sides. Whenever you apply a square root, you gotta remember to put the plus or minus in front. Okay? Over here, we're going to raise the reciprocal power in this one, which happens to be 2/3. Now, you might be saying, well, this isn't a square root, and it's a cube root now. We're applying a cube root, and then we're going to square it, right? The denominator indicates the root. The numerator indicates the extra power that we're going to do after the root. So if I were to take the cube root of 8, there's only one answer to that. The cube root of 8 is 2. And then I got to square the 2, and I get 4. So there's no need here, since we're doing a cube root. There is no plus or minus, is not needed. Okay? No plus or minus needed in this problem. We're doing a cube root. And we can just continue on through. We do have to check to see if we get an extraneous solution, which I don't believe we do, right? Because if I take the 8 and plug it in, 8 minus 4 is 2. The square root of 8 minus 4 is 4. The square root of 4 is 2. I'm getting ahead of myself. And cube that and you get 8, so it works. So as you can see, when we applied, and this goes for not just square root, but even a 4th root, if you have to raise to a 4th power, okay, you might have to use a plus or minus. Anytime you're doing an even root and you're applying it to the equation to solve it, you need to remember your plus or minus rules, all right? So hopefully this helps out. I know they use some funky absolute value notation when it's absolute value of, when the square root, the nth root of x equals, anytime the n is even, they go through this whole long drawn out process. So you have to use absolute value, and then you have 2 equations to solve. I know what we did with completing the square. I think this makes it much more understandable than the way they talked about it in Edgenuity. So hit me up if you want me to go over some personal examples with you. I'd be glad to later.